11,000 meters underwater, in a place with no light and pressure strong enough to crush steel. Something is happening that could change global power forever. While most nations are looking up into space, one country is quietly building an empire beneath the ocean. And no one's talking about it. Until now. While most of the world isn't paying attention, China is moving fast, building technology that can survive these extreme depths and stay there. They're not just curious. They're focused, organized, and serious. And they're doing it for one reason: control. You see, this trench, the Mariana Trench, holds more than just strange creatures and mystery. Beneath the mud are rare metals that could power the next century. Around it, fragile ecosystems that no one fully understands. And running across its floor, cables that carry the world's internet. This place is no longer science fiction. It's becoming the next strategic hotspot. And the decisions made down here could shift the global balance of power. As China dives deeper, other nations are falling behind. The question isn't whether this matters. It's whether anyone else is even ready for what's coming. Because the final race for resources, control, and security may not happen in space. It's already started deep beneath the waves. The abyssal chessboard, far out in the western Pacific, east of the Philippines, there's a crack in the earth so deep, it makes Mount Everest look small. This is the Mariana Trench, a 2,500-kilometer-long scar beneath the ocean, stretching down nearly 11,000 meters, at its lowest point, known as Challenger Deep. The pressure is so intense it's like having 90 adult elephants pressing down on every fingertip-sized patch of your body. There's no sunlight, no sound, and very little life, at least. That's what we used to think. For decades, this part of the planet was mostly ignored. Not because it wasn't important, but because it was too hard to reach. No normal submarine could survive the pressure. The equipment was expensive. The risks were high. So it was left alone, untouched, unseen. But now that's changing. New underwater robots and pressure-resistant machines are making it possible to go where we couldn't before. And while most countries are still trying to figure things out, one nation is already far ahead. China. Quietly, methodically, they've been sending vessels, dropping machines, and setting up plans to control what's down there before anyone else does. And it's not just curiosity that's driving them. It's about power. It's about access. And it's about who will benefit the most from what the deep sea has to offer. The Mariana Trench isn't just a crack in the seafloor. It's becoming a battlefield, not with weapons, but with machines, strategy, and long-term planning. Because, as surface resources run dry and competition heats up, the ocean floor is starting to look like the next frontier. And whoever takes the lead here may shape the balance of power for the rest of this century. Descent into the unknown. When we think about the ocean, we usually picture clear blue water, sunlight filtering through the waves, and colorful coral reefs. But that's just the surface, literally. That top layer, where most of the world swims, fishes, and surfs, only goes down about 200 meters. It's called the epipelagic zone, and it's where the ocean feels most familiar. But just below that, everything starts to change. Go a bit deeper, between 200 to 1,000 meters, and you reach what's called the twilight zone. There's still a bit of light here, but not much. It's dim, quiet, and cold. The pressure builds up to 10 times what we feel at sea level, enough to crush most surface-dwelling animals. Yet even here, life continues. You'll find strange, almost alien creatures, like the oarfish, a snake-like giant, longer than a bus, and sea angels, which are tiny, ghostly slugs that seem to fly through the water, keep going past 1,000 meters, and the light disappears completely. You're now in the midnight zone, a pitch-black stretch of water from 1,000 to 4,000 meters deep. This is where some of the ocean's weirdest lifeforms exist. Many of them create their own light, glowing in the dark through a natural process called bioluminescence. Down here, fish have massive eyes, see-through skin, and teeth so large they can't even close their mouths. Beyond that is the abyss. Between 4,000 and 6,000 meters. It's colder than ice, almost silent, and looks empty at first glance. But that's where things get interesting. Over millions of years, everything that dies in the ocean, from tiny plankton to massive whales, eventually falls to the seafloor. It builds up slowly, layer after layer, like snowfall. Scientists call it marine snow. It may look like mud, but it's packed with ancient carbon, trapped and stored in ways we're only beginning to understand. And, at the very bottom, below 6,000 meters, lies the Hadal Zone, the trench territory. Light doesn't reach this deep. The pressure is hundreds of times stronger than at the surface. Yet somehow, life has still found a way to survive, from tiny shrimp to single-celled giants that live in silence. This deep ocean isn't empty. It's just waiting to be understood. And for those who reach it first. The potential rewards are enormous. Challenger Deep, where legends go. At nearly 11,000 meters deep, the Challenger Deep is the lowest known point on Earth. It's so far down that it's deeper than Mount Everest is tall. For most of history, it was completely unreachable. That changed in 1960, when a Swiss engineer and a US Navy officer descended into its darkness inside a steel sphere. They stayed just 20 minutes. Then, for over 50 years, no one returned. In 2012, filmmaker James Cameron made a solo descent and captured never-before-seen footage. A few years later, millionaire Victor Vescovo built a high-tech sub and completed multiple missions, collecting data and samples. Each of these dives made headlines. But here's the catch. They were one-off missions, rare, expensive, short-lived, and then China entered the picture. In 2020, they sent a submersible, called Fenduji, with a full crew to the bottom. But unlike the others, China didn't treat it like a one-time win. They built smaller, smarter machines. They started repeating missions. They made deep-sea access routine, not rare. This shift from record-breaking to repeatable changed everything. Because once you can send machines down again and again, that's when strategy begins. And China isn't just catching up. They're building momentum. Robots, bases, and cold seeps. By 2024, China had gone beyond sending human crews. They were deploying small autonomous robots, no bigger than a shoebox, thousands of meters below the surface. These machines had no cables, no pilots. They crawled along the seafloor, did their job, and came back intact. That changed the game, because if one robot can survive that pressure, you can build a fleet. And if a fleet can work together, mapping, collecting, analyzing, you've built a permanent system. One that costs less, works faster, and gathers more data than any submarine ever could. But what are they looking for? Some targets are biological, like cold seeps. These are areas where gases, like methane and hydrogen sulfide, leak out from beneath the seafloor. Life forms here don't use sunlight. They survive by feeding on chemicals, tube worms, clams, bacteria. These sites don't just teach us how life works in extreme places. They might also help us understand alien life on planets like Europa or Enceladus. And then there's fire ice, methane trapped in frozen water. If you light it, it burns. That's potential fuel. China's watching it closely. But it's risky. Disturb the seafloor too much, and you could trigger landslides or release greenhouse gases. They're also preparing to build a permanent underwater lab, minus 2,000 meters deep, like a space station, but underwater. Scientists would live and work down there for weeks at a time. That kind of presence gives China time to test tools, monitor the seabed, and prepare for long-term control. the resource gold rush. At first glance, the seafloor looks like nothing but mud and rocks, but buried within that silence is something the world badly needs: raw materials. Scattered across the bottom are strange, round rocks called polymetallic nodules. They're about the size of potatoes, and they contain valuable metals like cobalt, nickel, copper, and manganese. These are key to making electric vehicles, solar panels, and batteries. Here's how they're collected. A ship on the surface lowers robotic crawlers to the seafloor. These machines scoop up the top layer of sediment, nodules and all. Everything is pumped back up through a pipe to the surface. But there's a problem: sediment plumes. These clouds of disturbed particles don't just vanish, they drift. They can smother sea life, cover habitats, and disrupt fragile ecosystems that took millions of years to form. Scientists are worried. We haven't even discovered half the species down there. And once we start ripping up the seafloor, there's no easy way to undo it. Still, companies and countries are racing forward. Why? Because whoever starts first, learns fastest, builds the tools, sets the rules, and that edge could shape how deep-sea mining plays out for decades. Geopolitics underwater, underneath. The ocean, another war is already brewing, not for resources, but for control of the world's information. Fiber optic cables stretch across the seafloor, carrying more than 95% of the planet's internet traffic. Emails, bank transfers, military commands, all of it. These cables are thin and vulnerable. One anchor can knock them out. In recent years, Russian ships have been spotted near undersea cables in the North Sea, raising red flags. Then, in 2025, China revealed a deep-sea robot designed to cut and repair cables. Officially, it's for maintenance. But if you can repair a cable, you can also sever it, quietly, invisibly. This isn't science fiction. It's modern warfare, silent and underwater. China is also outspending others in ocean science. They're building labs, funding top universities, training engineers, attracting global experts. Meanwhile, the US is cutting budgets. NOAA, the agency responsible for protecting American waters, has seen its funding slashed. This imbalance matters, because the deep sea isn't just a new frontier, it's a new layer of global power. Whoever controls it, controls the cables, the resources, the surveillance systems. That means control over everything. The last, untouched frontier. The Mariana Trench used to be a blank spot on the map. Too deep, too dangerous, too mysterious. But now, it's becoming a prize. China isn't just studying it, they're preparing to own it. With constant missions, robotic fleets, and plans for permanent stations. They're turning rare access into regular presence. Every cable laid, every robot sent, it all adds to their advantage. Meanwhile, much of the world is hesitating. Budget cuts, delays, uncertainty. Scientists are sounding the alarm. They say we're moving faster than our understanding. That we could wipe out species before we even know they exist. That some damage may never heal. The trench is becoming a proving ground. But this isn't about flags or bragging rights. It's about who controls the future, not above us, but below. A call to depth. The deep sea isn't empty. It's full of power, and one country is reaching for it with both hands. China is building, testing, repeating. Others are still deciding if they even want to compete. We've seen what's possible when nations collaborate. Look at the space station. That same mindset could protect the oceans. But if one country takes the lead while the rest watch, the consequences won't stay buried. This isn't just about geology. It's about energy, security, and global stability. What happens down there will shape what happens up here. The real frontier isn't above us anymore. It's beneath our feet. And it's already in play.